Okay, so we are going to finish up the section 1, chapter 7. Got 3 more problems. So let's see, we're going to do 55. So 55 is another one of these questions of whether it's conditional, an identity, or contradiction. So 55, let's write that down. I can't copy the wrong problem here. So 55. So we get negative 11x plus 4 times x minus 3 plus 6x equals 4x minus 12. Okay, so first step, get rid of the parentheses by multiplying out by unsimplifying. So 4 times x is 4x. 4 times negative 3 is negative 12. Okay, combine like terms. Got negative 11 plus 4 plus 6. So that's 6 plus 4 is 10. Minus 11 is negative 1. So we get negative x from these 3 terms. There's only one constant term. And the right-hand side stays the same. Okay. We want to get the variable terms to the left-hand side, so I'm going to subtract 4x from both sides. I'm going to eliminate that on the left-hand side, so I'm going to add 12 to both sides. So negative 5 minus 4 is negative 5. So I get negative 12 plus 12 is 0. Negative 12 plus 12. See, that's unusual. So in this case, this goes to 0 and this goes to 0. So the right-hand side is 0. You divide both sides by negative 5. So this negative 5 divided by negative 5 is 1, so you get 1x is equal to 0 divided by negative 5, which is 0. And some people make the mistake of going, oh, x equals 0, that must be some weird special case. But it's not. All it is it's the solution is x equals 0. x0 is a number, and it's just a number like any other number. So it's not a special case. So because of the fact that there is a conditional response to this, meaning there is one condition where that is true, then it is the conditional, and that's what most of them are. And the condition is the number 0, meaning that this original expression is satisfied, meaning the equality is satisfied if x equals 0. Now the third case, which is an identity, and I don't think I signed this, but if you look at 47 and 48, 57 and 58, what you'll end up with is something like 0 equals 3. And if you end up with this kind of thing where you just have 2 different numbers on either side of the equal sign, this is where it's called, well, actually that's a contradiction. But if you ended up with the x parts cancel out, but you end up with 5 equals 5, or 7 equals 7, or 0 equals 0, anything where you get the same number on both sides of the equal sign, that's an identity. So I'm just going to show you, I didn't assign one for homework, but let's just show you an example, just so you know what that is. So this is 57. Okay, and one thing that's also different here is you've got this square bracket, and the reason you could use just a curved bracket, like a parentheses, but sometimes people use different ones when, this would be the innermost term, and this would be an outer, further out. So what you do is, in this case, you perform the operation inside the inside parenthesis which in this case is all it is we're taking a negative sign and applying to each term. So we're going to change the sign of each one of these, or you can think we're multiplying by -1, either way. So that's the first step here. Now you might be tempted to try to do more than one thing at a time, but unless you're a math major or me, you probably shouldn't do it. So the next thing we do is we combine like terms inside the square brackets. And the only like terms we have are these two. So 2 minus 3 is -1. I haven't done anything on the right-hand side yet, but I will in the next step. So here I'm going to multiply 7 times each one of these terms. So 7 times -1 is -7. 7 times -4 is -28. So -7 times -4x is -28x. Let's bring this term down. Okay, then I've got 2 times 1, which is 2. 2 times -15. 2 times 15 is 30, so I get -30x. Okay. Now we're going to combine like terms again because I've got all the terms separately. So we only have one constant term here. Then you have -28x minus 2x. So -28 minus 2 is -30. Remember, if we start at -28, which is to the left of the 0 on the number line, and we subtract 2, subtract means go to the left, so it becomes more negative. And so we get -30. From first semester, the people who took first semester already, remember, if you have 2 negative numbers, you take the absolute value of each one of those and you add them together. So you take 28 plus 2, which would be 30. But because these are both negative signs, you'd end up with a negative. Okay. On the right-hand side, we've got 2 constant terms. So we have to combine those two by doing the operation. -9 plus 2 is -7 again. And then we start at -9. We go 2 units to the right. Since we're adding, that means you go -9, -8, -7. And you might notice at this point I've got exactly the same thing on both sides. So I could just say at this point that this is an identity. Identify, identity. So, or you could subtract, you could add 7 and add 30x to both sides. So I'd add these, and what I end up with is 0 equals 0, and that is the case for an identity. Or I could have just added 30x and I have -7 is equal to 7. So once you get to the point that you know there's exactly the same things on both sides, then you can say it's an identity. So that's the third case. Okay, what are we doing next? 63 and 65. So all of Chapter 7 is dealing with you're solving for one variable, one unknown. In this case, all the previous examples, the unknown is x. What is the value of x for this equation to be satisfied? Now, in reality, most of the time what you have is you have an equation and you know all the variables except one of them. So I think maybe in class, if I was looking at the force of attraction between 2 bodies, I'd have this constant g, it's just a number. I'd have the mass of the 2 bodies, and I'd have the distance between the 2 bodies squared. So, this has got lots of variables. Seems like it's a lot more complicated than this, but to solve for the force, to calculate the force, I'd have to know all these numbers. So even though the equation has all these variables, all the variables are known except for one of them. In this case, if I'm solving for the force, I need to know all three of these other variables. So if I was given M1 was 5 kilograms and M2 was 2 kilograms, and I know G is some number, and I don't remember the exact number, but it is known, and the distance between the two objects is 1 meter. Then I know all these numbers and I just plug them in and I get the answer. Now the question is, what if I knew everything, I knew the force and I wanted to calculate the mass? I need to rearrange this equation to solve for one of the other variables. And then I'd have to know all the others. So let's, if I solve for M1, I'm just going to show you what the result is. If I solve for M1, I'd end up with this equation. I'd have to know all three of these variables plus I already know what the G is, and then I plug the numbers in. So these numbers over here are known. These numbers here have to be known to solve for it. So you have to take an equation and be able to solve it not just for the one that's originally solved for, in this case force. You have to be able to move these things around and solve for the variable that you don't know. So that's what these problems are doing. And 63 uses the equation area for a parallelogram is equal to the length of the base times the value of the height. So if I knew the base and the height, then all I'd have to do, if I'd say base is equal to 1 inch and height is equal to 6 inches, I could calculate the area by just plugging those numbers in. 1 inch, 6 inches. 1 times 6 is 6. Inches times inches is inches squared. And that would be my answer. But let's say I gave you the area was 8 inches squared and the base is equal to 2 inches. In this case, what is the height? There's only one height that's going to make this work. So you could plug these numbers in, or you could solve for h. So the way you would solve for h is you would say you take your equation here and you divide both sides by the same quantity. In this case, since we're solving for h, we divide both sides by b. So that we have b over b. And no matter what b is, this ratio is 1. So you get A over B is equal to H, 1H, or H is equal to A over B if I switch the things. So that's the kind of thing that we're looking at doing. In this case, they're asking to solve for the base. So you start with the original equation, and you're going to be given the area and the height, and you want to know what the base is. So what I would do is I would divide both sides by the height, because I'm trying to solve for the base. I want to get that by itself. So height divided by height is 1. So I get A over H is equal to B times 1, which is just B. B is equal to A over H. So that is what they're looking for. It says solve each formula for the specified variable and ask to solve for B. Now 66, you've got volume is equal to length times width times height, and they want you to solve for h. So they want you to have some equation that says h equals something that's a relation, some combination of these other variables. So if I was given the volume, the length, and the width, I could calculate the height needed to make that be true. So how do we do that? Well, we take the original equation and we say, okay, well, I want to solve for h. I want this by itself, so to do that, I have to divide both sides of the equation by the same thing, which is the terms that are not h. in this right-hand side. And the reason you do that is because L over L is 1, W over W is 1, so we can simplify this as being L over L is 1, W over W is 1, H just stays there because we're not dividing that by H. 1 times 1 times 1 times H is H, so the height is equal to the volume divided by the length divided by the width. And that's what we're looking for. And as just one additional example is 69. Here, this is the surface area of a right circular cylinder, 2 pi r times h, which is the outside of the can. And then you have the ends of the can, 2 pi r squared. What you have is pi r squared, which is the area of the circle, which is the end of the can. And there's 2 ends of the can. Okay, so what they're saying is solve for h. That means they're going to give you S, the area, surface area. They're going to give you radius. What is the height you would need to get the specified surface area? So to solve for h, these don't involve h. So anything that doesn't involve the variable you're solving for, you're going to subtract. So we're going to subtract 2 pi r squared. Now let's do it. Let's do it the way that we did it with. So let's say you take S is equal to 2 pi RH plus 2 pi r squared. So what we do is subtract 2 pi r squared for both sides. And what that does is it's going to take this term and put to the other side appropriately. It's going to leave me a term with just the h. It's just like we did here, where we, well actually, yeah, I think we did it here. You know, we were, well, that's, yeah, some of the ones we've already done, which I can't show you. Okay. Well, what this does is by subtracting this number, or this expression here, this is going to go to 0. So what you would end up with is S minus 2 pi r squared is equal to 2 pi r h. So this comes down because we haven't done anything to this. This term goes to 0 because I'm subtracting the same thing that I'm adding here. Now, to solve for h, I need to divide everything. I need to divide this side by 2 pi r, so I get 2 over 2 is 1, pi over pi is 1, r over r is 1, so this thing becomes 1. But because that's what you have to do, and I think it's, yeah, that's right. Okay. I have to divide both sides by the same quantity to maintain the equality. And what's going to happen is, like I said, this is 1, this is 1, this is 1. So I'm going to have 1 times 1 times 1 times h. I'm just going to have h. And you could say that's done. I always like to put the variable you're solving for on the right-hand side or left-hand side of the equation. So I just switch the 2 sides. And that's how you would solve for h. It's just a little more complicated. But